water cannot curve around the exterior of an object without a force.
Yeah, gravity.
So how does that... Gravity is not a force.
Yeah, there's some physicists that'll say gravity isn't a force. I don't really know what they mean by that, but no, like you and I have weight. The weight is definitely a force and it's caused by gravity. So I just say gravity is a force. And if you want to like 4D chess checkmate me on that or whatever, then I don't really care, because in simple terms, that's how we understand these things.
But is there any experiment to back up this idea there's a force?
Of gravity?
Yeah.
Yeah, for example, accelerometers, when they're at rest on the ground, they measure an upward force, and that's like the equal and opposite reaction type thing. That kind of supports gravity in a way, or that gravity is a force. There's this other really cool experiment that Steve Mould did, where he took the beads that self-siphon out of a beaker, and he proved that there's an upward force pushing on them, and that's an equal and opposite type of force, which isn't like strictly gravity, but the weight of the object, that's the force caused by gravity and pushing back. But what I would say is, whether or not you want to call it a force, we can describe this phenomenon of gravity in mathematical equations perfectly. And there have been so many testable novel predictions that have come true thanks to that in all kinds of different ways. Everything from the relativistic effects that satellites experience by being farther away from Earth, and then therefore time ticking at a different rate for them, to gravitational waves being detected.
Okay, so I mean, you said quite a lot there, yeah. So yeah, what you've told me is about the hypothesis. So you're saying that an effect happened, something is happening, and we think it's because of gravity, which I understand.
That hypothesis has been demonstrated to be confirmed so many times that it's now the theory of gravity.
But that's what I'm asking. You're saying that, yeah, we've had this idea that things fall, things go up, things go this way. Yeah, I get that part. So we're trying to figure out what is causing that, right?
Yeah.
So how do we test? Like if it was magnetism, we could turn the magnet off, we could turn it on, we could increase its magnetism, we can lower it. So we could test if it was like magnet, right? If it was electricity, we could turn it down, turn it up, turn it off, turn it away, put it on, make things go that direction, that direction. How do we do that with gravity? How do we make things go up, down, left, right, stop in the middle and fall using that force?
We figured out how to do this in the 1700s. It's called the Cavendish experiment.
Mm-hmm.
Yeah. So you can make things go left, right via the gravitational force with an experimental apparatus known as the Cavendish experiment. So you're only 300 years behind.
Has that ever been observed with in a vacuum?
In a vacuum, probably. I'm not aware of any examples of it being done inside of a vacuum chamber, but they've done it inside of a Faraday cage, to completely eliminate any stupid electrostatic.
That's one variable you can't afford. Good. What about magnets? What if it's magnetism?
That you do it with lead, which does not conduct a magnetic or electric current.
That's good. So you check for magnetism, you ruled that variable out. You check for electricity, you ruled that variable out. Yep. What about the air? The air's moving constantly. Did you remove the air?
You can do it in a room where the air is not circulating. And also, when they do these experiments, the thing tips and then touch, like it's like lead balls, right? So it'll move and it'll touch, and then what people do is they go in and they move them again, and it goes and finds it again, or they'll switch it to the other side and it just goes to the other side. So you can argue that there is somehow an air current in there that somehow always pushes the apparatus toward wherever the weights are, because I've seen videos of people doing this. They take them and then they swap directions with them to watch them go back the other direction. So you can just claim somehow the air current always makes the thing tilt in that direction, but I think that's too stupid to take seriously.
So you're saying that it could be one of those variables?
In the sense that literally anything is possible, it could also be unicorn farts, but it's completely unsensible to think that that's what it is. Have you ruled out unicorn farts?
How would you remove it? How would you know there's unicorn farts? How do you?
You're the one with the burden. The unicorn farts hypothesis isn't a model, so you're the one with the burden. If you want to try to prove that it's not that.
If I said unicorn farts is the cause of the movement, I would have to show unicorn farts, right? So if I'm saying the air...
Yeah, I'm not saying it is unicorn farts. Look, I'm not saying the earth is flat. I'm just saying... I'm not saying it's unicorn farts. All I'm doing is saying that you haven't ruled it out.
Well, again, you can't rule it. It's not something that we can manipulate, right? We don't observe unicorn farts.
Okay.
So we observe magnetism, we observe electricity, we observe the air movement. So those variables we should account for, right? Because we know the air moves, heat rises, yeah? So therefore we should put Cavendish in a vacuum to see if there's still an attraction. And I would say...
And what if that has been done?
If that has been done, then you've got your gravity. But I would say that nobody has ever seen mass attracting mass in a vacuum. Therefore, you don't have science, you have like a religion, an idea.
You know the moon orbits the earth, right?
Again, that's looking at a phenomena and hypothesizing what the cause and effect is.
So you know that the moon orbits the earth, right?
Yeah, whatever you...
Okay, so we have mass attracting mass in a vacuum. There we go.
Yeah, that's what I'm saying. You're looking at the moon and you're saying, I think that's in a vacuum. I think
no, we know it's in a vacuum.
How?
Because we've been to space.
How would you get to space?
In a rocket.
Rockets don't work in a vacuum.
What does that mean?
Rockets need air to push off, like an aeroplane, like a car on the road, a boat
no, they
on the
don't.
water. A car pushes off
No, they
the road.
don't. Well, okay, yes, a car does that. Do you know why? So if you turn on gas pressure, if you turn on a hose, the hose is going to go...
Because of the air, yeah.
No, not because of the air, because there's an equal and opposite reaction. It's pushing off of itself. When a bomb explodes, why does it go in all directions? Is the bomb pushing on the air to move itself in all directions?
Well, that's pressing off the device, right?
Yeah, like a garden hose, or like a rocket. If you blow up a balloon and you let go of it, it doesn't push against the air. Air has no substance. Notice how I'm not moving, even though I'm pushing against the air, right?
You're moving the air, though.
Yeah, I'm moving the air, but that is not sufficient to get my mass to move. So a balloon moves through the air because the pressure inside the balloon pushes, as that air escapes, it pushes back on the balloon. That is how a rocket works. We know that. And you guys somehow think that the only way for a rocket to move in space is if it keeps up with the propulsion. No, because an object in motion will stay in motion unless acted upon, and in the vacuum, there's no air resistance.
All right, let me show you how this works. Because I deal with demonstrations, not like a religious idea of what you think will happen, but what actually does happen, right?
Yeah, so for example, you could, the rocket inside the vacuum.
Okay, so look, let's take a look at this here.
Yeah, and it moves.
Okay, I'm going to show you, look.
Great.
So this is what we would call like the mini rocket, and that there's going to be like gas coming out of this syringe, right? Let's forward this a little bit.
Do you simply reject that for every action there's an equal and opposite reaction?
No, that's in the atmosphere. In a vacuum, those laws don't work.
Yes, they do.
Well, I have the demonstration to prove otherwise.
No, you don't. If you were on you ever been on a skateboard before?
Okay, look.
Have you ever been on a skateboard before?
Yeah, same principle. I hold a bowling ball,
So
throw the bowling ball, I should go backwards, yeah?
yeah, not because you're pushing against the air, because when you
Because I'm on the,
threw the bowling ball, there was an equal and opposite force being pushed back against you.
but if I wasn't on the ground, that wouldn't happen.
If you were in the air, it would happen.
Well, here's an example. Right. So we have an ejection of gas leaving the syringe, and the syringe doesn't go backwards until the gas hits the wall. You see that? Hits the wall.
It has inertia. In order for what you're explaining to be true, then what that would have to mean is that the air is rigid, and even an idiot like you knows that the air is not rigid.
So here's a vacuum.
Is the air rigid?
There is no air inside.
Is the air rigid?
The air, there's no air in here.
Is the air rigid? Is any air at any time rigid?
No.
So then why did you say, oh, look, the syringe doesn't take off until the air escapes and touches the wall of the vacuum chamber?
Yeah, when the gas builds up, it builds up pressure hitting the wall, causing the syringe to go backwards.
No, it doesn't.
So what happens? Why did it go
An
backwards?
equal and opposite reaction.
But we're not observing that in a vacuum.
Yes, you are. Because it ejected the gas and it moved forward.
Let's take a look.
We did take a look. It ejected gas and moved forward.
Not until the gas hit the wall.
That doesn't matter because it's not, the air isn't a stick. That's, look, I'm not moving yet until, oh, my stick touches the wall. Now I'm moving backwards. Air is not rigid, okay? So you need to stop pretending with this one.
All right, let's take a look. There's no movement. So I throw the bowling ball, no movement. Now there's movement.
We're not doing this. What's your next talking point?
Well, that is my point, is that rockets cannot leave the enclosed system. There was no evidence of rockets leaving an enclosed system.
There's literally cameras that have been strapped to them that have recorded them going up into space.
Yeah, they go up, then they turn off.
Yeah, they go up into space, and then eventually they turn off.
That's not what we observe.
Yes, it is. They go up until their surroundings are completely black, and you can see the haze of the atmosphere below them.
Well, I mean, if you could show one, that would be great. But as far as I'm aware, they go up, they turn off to avoid the dome, and then they come back down. Do you have a video of them going up, going beyond the dome?
There is no dome, so in a way, the answer to that is no. But in another way, the answer is yes.
All right, can I see it?
I know you've been shown this before. I can't. My phone is mounted to a clamp, and if I take it off, then the microphone will disconnect, and then I will lose all my audio recording, which I can't have that happen because this is how I make content. But you can look at this whenever you want. Fine. I will be live streaming again tomorrow, so you can come with any video you want that shows this not happening or whatever.
No, I get it. So you can't show gravity being a force with an experiment, but
Have
yet you
done
believe.
that, yes.
Who's done that?
I gave you examples.
Yeah, but we've never seen it in a vacuum. Remember?
Yes, yes, we have actually. So,
why would you lie to your audience? You've never seen Cavendish in a vacuum.
According to I didn't mean Cavendish. There are other ways you can do this. So, according to the flat Earth model, according to the there is no such thing as gravity model, if you put something on a scale, and then, let's say we put something inside of a vacuum chamber on a scale, but there's air in it. So we have this object on the scale, and then we remove all of the air. According to the gravity doesn't exist model, would the weight of that thing increase, decrease, or stay the same?
So the pressure on the scale would change, yeah.
Would the weight increase, decrease, or stay the same?
If you'd remove the air, the pressure would be reduced, obviously. If you increase the air, the pressure is increased, obviously.
Would the weight increase, decrease, or stay the same?
This is what I'll try to get. Weight
Would
comes
the
from
weight
where?
increase, decrease, or stay the same?
I've just told you it would be less.
It would weigh less? No, it weighs more. Congratulations. So
If I
the
took air, if I
gravity
took
does,
air
hold
out-
on, time out. The gravity doesn't exist model has a specific prediction given by you that when we remove the air, it weighs less. That is the opposite of what happens. It weighs more. So congratulations. We have confirmed
would
the
weigh more?
gravity is real.
I'm asking you what would weigh more?
I'm not giving you an answer so you can change the story about what you were trying to say.
You said remove the air, it weighs more.
Yep.
So if I've got an empty vacuum chamber with a scale in it, what am I weighing?
Whatever's on the scale.
So how would I get more if I've taken stuff away?
I could tell you, but it's actually just so incredibly funny that you don't know high school physics, so I'm not going to tell you.
Do you know the answer?
Yes.
What is the answer?
I'm not going to tell you because it's so much funnier that you don't know the answer. When I upload this to YouTube, I'll put it like in text, the explanation for the answer. But yeah, funny enough, the answer has to do with gas pressure. But yeah, I'm not going to tell you because you existing in ignorance is more funny to me than me educating you about this.
I mean, I could say the same for you, but we're trying to get to a resolution.
You can't though,
right?
because I'm not an ignoramus.
You are ignorant. You don't have science to back up your claim. You have beliefs.
I have scientific beliefs and experimentation. For example, if you put something on a scale and then put it in a vacuum chamber and then take all the air out, according to the gravity doesn't exist theory, it'll get lighter. Oh no, it actually gets heavier. So the idea of gravity isn't real is debunked. But that is consistent with the gravity does exist model.
So you're saying I put an object on a scale, I remove the air, it will weigh more.
Yep.
Okay, can you show that?
Again, you can look up a video of this. We can actually think about it together and it's going to make perfect sense. So air and then no air is, you agree that air is a fluid, right?
All right, if you say so.
So air is a fluid. So if we have air and then no air, what I'm telling you is the thing will weigh more, right?
Way more. I mean, I don't see how, but okay.
So if we take a fluid, going from air to no air is, in a sense, like decreasing the density of a fluid. And as we decrease the density of the fluid we exist in, we weigh more. Are you with me so far?
I mean, if you say, I'd have to see a demonstration for that.
Sure. You ever go swimming?
Sure.
Have you ever tried to pick up something in the water? Something really big and heavy?
Sure.
It's easy to do, right?
It depends.
No, it doesn't depend. So you can lift heavier objects in the water than you can in the air because when the density of the fluid decreases, things become heavier. I'm not going to give you more of an explanation, but I have now proven this to you according to your own standards.
Well, you've given your version of an explanation how you think things work without a demonstration.
No, there are demonstrations of this.
I mean...
Good old Action Lab, he's done this before. The guy who you stole that last video from.
Well, how's that stealing? I'm showing an example of how rockets don't work in a vacuum.
I didn't mean you committed a crime, I'm just saying.
Yeah, but that's what it's there for. It's there to be used, right?
Yeah, again, I didn't accuse you of committing an immoral act. It's just the word steal. Don't get offended.
Yeah, but I'm saying there's nothing wrong with me using it.
It's just a word, not a globe. It can't offend you.
All right. So what's the name of that experiment?
I don't know. Kim Kardashian full frontal exposed 4K 60 FPS. That's probably the name of it.
No, not what's on your computer. I'm talking about the experiment.
Oh, sorry. My bad. Yeah. No, I don't know what it's called. So just, I don't know, do some creative Googling and you'll find it.
Okay. So how is anyone supposed to take the globe seriously when all you say is it's over here, look over there like a magician, look over there. You know, my hand is here, my trick is over there. What do you have personally to prove that what you've been told is true? Not much, right?
The night sky rotates in two different directions, which is literally impossible if the Earth is flat, but it's exactly what you would expect on a spinning Earth.
Yeah, that's just an observation. We can assume what's happening with that observation. We can't verify it for sure, right?
That's one way of putting it.
Exactly. It could mean anything. It could work on a flat Earth. It means the sky works in a particular way that we don't understand. That's not proven if the Earth is curved or flat, right?
The totality of observations increases. How do you want to say this? It multiplies the, I guess you could say, odds. I don't know. There's probably a better way to say this, but my words are failing me.
Same thing could happen for Jesus and religion. The odds of Jesus living, walking, dying on the cross are very high. People witnessed it. People wrote about it. It could say the same thing. So you have a religious belief that you cannot verify.
No, because mine's predicated on evidence and co-referential experiences, and it continues to make new observations. No, because mine continues to make new observations and new predictions that come true.
All right, let's have a look. You can't show them, right?
Yeah, I can.
Where are they?
Sure.
Give me the name. What do I type?
So unless I can give you something to type on your computer, you're not going to buy it?
I'm pointing out there's no difference between your belief and a religious person. The religious person says it's been verified, we've checked it out, we've got historical, we've got experts. You would say the same thing. We've got experts, it's been verified, we've done it.
Yeah, but mine continues to be verified. Day.
Yeah. Same thing with God's creation. They could say we have new creation every day.
Those are post hoc rationalizations. Those aren't testable novel predictions.
The point is it's talk. You're talking and they're talking.
No, science does things. Name one. What is the greatest discovery in the history of religion?
What do you mean discovery?
What's the greatest discovery in the history of religion?
I don't get that question by discovery. What do you mean
discovery? Because it's a nonsensical question, because there are none. Whereas the greatest discovery in the history of science, it'd be impossible to pick just one. Because they happen day.
It makes sense. It's ongoing. It's every day. People are religious every day.
Yeah, and name one discovery in the history of religion.
Discovery like what?
Exactly.
What does that mean? Yeah, but what does that mean?
Exactly.
It's a nonsensical question.
I know. It's really not a nonsensical question. It just doesn't have an answer.
Well, what is there to discover?
Literally anything, and yet it doesn't ever do anything.
This doesn't make sense. You have a Bible.
I know.
You read it. Yeah, you have a book. You read it. You understand the world around you, and then you have faith in what you believe. The same thing happens with you. You have a book. You read it. You listen to people.
We make testable predictions. They come true. We have verification for our beliefs.
I've asked you to name one. You can't remember the name. I asked you to provide something.
I've named several. So I can give you another one. So if the Earth is flat, let me get rid of my background here so I can show you this. If I can remember how to even do that.
So, because what I like to do is point out there's no difference between the glober and a religious person.
This is a flat Earth, right?
Okay.
So if the sun is going to rise for somebody in the southern hemisphere, then the sun will always be northeast of their position, right?
Again, I know what you're saying, but we don't know how the sky works.
Yeah, we do, actually.
That's what you might expect, yeah. If you expect in this model, the sun would come from the northeast and set in the northwest.
Yep. But in reality, like in summer for the southern hemisphere, like it is right now, the sun rises in the southeast. That just simply does not match reality. This is a model. This is an accurate flat Earth model, except it doesn't represent reality. Whereas the globe model accurately displays, it accurately, how do I want to say, like mimics or whatever, what happens in reality. Your model doesn't do that. So we have an accurate model. And you don't. Nana nana boo boo, stick your head in doo doo.
We've never claimed to have a model.
Yeah. So what are models? What are models and what are they used for?
So models are for making predictions
And
and
you can't
prescribing
make
what.
any.
Yeah, because we're not claiming to have a model. Models are a reification fallacy. There's no concreteness to your model, like I've just pointed out. You don't have gravity, so there's no concreteness to that.
No,
You
we
don't
do have
have
gravity.
curvature. You just keep saying it, like a religious person. You can't show curvature. You
Yes,
can't
we
show the
can.
Earth rotate.
Go outside and
Again,
look at
like
the horizon.
the horizon is not physical; it's apparent.
Yeah,
So because it's not
that's consistent with the globe Earth model.
on a globe, you would have a geometric point where things disappear. That doesn't
No,
happen.
because the surface is not perfectly smooth, and because the curve is extremely gradual, it's sort of like it's almost like an asymptote. It's you can't say right here it starts and the Planck length after that is where it ends. It doesn't work that way. But there is definitely a horizon because there's a sharp line. It wobbles a bit because of things like waves or whatever. It's easiest to do this at the ocean. But there's a sharp line where the sun and the sky or the sky and the water meet, and there are things behind that sharp line that we can see, but we only see the top parts of them, not the bottom parts of them.
Yeah, and that sharp line is meant to be fixed. And what we've found out after research is that the horizon fluctuates. So if I'm a 6 foot observer, that horizon is supposed to be 3 miles away from me. But if I go there on Monday, it's 2 miles away. I go on Tuesday, it's 7 miles. I go there on Wednesday, it's 10 miles. So every day that horizon that straight line you're talking about is constantly moving in different places. On a globe, it should be fixed at one point, one position, where for the observer to see things disappear beyond. That doesn't happen. So that's how we falsified your radius.
That's completely incorrect. The point, like the so what you're doing is saying, well, the physical point, assuming no whatever atmospheric interference or whatever, is at this position. That's always true, but the atmosphere does do weird things. But the idea that one day you went somewhere and the horizon was only 2 miles away from a 6 foot observer height, that's obviously false.
All right, look, I can show you. Again, we don't just talk. We're not religious like you guys are. We show you in the real world what is happening. So this is on one day. The horizon's this far in front of the platform.
Wow, the
Same.
atmosphere changes day to day. Congratulations, flat earthers have discovered weather.
So if the sun were to set on Monday, which horizon would it set? On Tuesday's horizon or on Monday's horizon? Which
Depends
one?
on the conditions of the atmosphere. Congratulations,
Exactly.
you've
Exactly.
discovered weather. So it
Exactly.
doesn't
So one
depend on the conditions of the physical earth, it depends on the conditions of the atmosphere. Congratulations.
I agree. Depending
Why
on the
is it?
atmosphere.
Why is it that you can see the top half of things behind the horizon, but not the bottom half?
Well, this is a great example. Look, Monday you can't see the bottom. Tuesday you can see the bottom. Depending on the atmosphere, like you just said, depending on the weather.
I
whether
have
we can
no idea if the person that took that picture took it from the same height, and neither do you. And there
Yes,
could be
I
a
do.
high
Yes,
tide
I
on
do.
one of those days. So the
Oh,
question is,
confused.
why is it?
Confused.
So the question is, why is it that we can see the top halves of things behind the curvature, but not the
Like
bottom
this.
half of those things?
I'm showing you as I'm telling you. Monday, we can't see the bottom half. Tuesday, we see the bottom half. If we check
I have
the video,
no idea from what
I
height
know.
both of those pictures were taken.
I understand. I get it. But this was taken from the same height on different days. Let me find where he says it in the video. Give me a second. It's along here somewhere.
Fascinating.
Hold on, there it is. There we go. Different day, exact same location, same elevation, right? So that's Monday. You said, I can't see the bottom. So what? Wait till the weather clears up. The next day, you will be able to see the bottom of that object, right? That's what real world research is, something you're failing to do. Now, look here, look. Can't see the bottom. Oh, where is it? It's gone. I can't believe it. It's disappeared on Monday. But on Tuesday, We just go to the same place and we can see it. Look at that, like magic.
Yeah, the
Wow.
atmosphere changes. Congratulations. So does this prove
Exactly.
that the Earth is flat, or does it prove that the Earth is not a globe? I think it proves that sometimes the atmosphere is slightly different. Let's pick a test that doesn't have any observable variations. Ready?
Yeah, sure. What do you got?
Who will see the sunset first? Somebody on the ground or somebody on top of a very tall building?
On top of the tall building.
You're a fucking genius, you idiot.
Oh, right. Sorry. Right. Set. Sorry. Yeah. Set the other way around.
Why is that?
Because you can see further, a lot further when you're higher.
So, the sun is the same distance from you in both examples.
No, but the horizon goes further out when you're higher.
How is that consistent with a flat Earth?
Because the horizon is not physical. If the horizon was physical, as I go up, I would look down beyond that horizon. But I don't. I look out further and see a horizon.
Wait, so are you saying that the sun actually does go below the horizon?
Appears to. But there's nothing can go below the horizon because it's not. There's no physical drop beyond the horizon.
Right. So, ignoring the fact that we have zoomed in footage of the sun physically disappearing below the horizon, why is it that somebody in a tall building sees that happen later?
Because they go higher. They're higher. They can see further.
Right.
The higher
So
you
how,
go,
do,
the
how
further
does
you can see.
that perfectly matches curvature? Because if the curvature is obscuring the sun, then the higher up you are, the farther out you can see. So everything that you're saying is completely consistent with a globe Earth.
Well, not
How
really,
is that
because-
consistent with a flat Earth?
Because on a flat Earth, you look straight out. On a globe Earth, you would look down. As you go higher, you have to look down at the ball. On Earth, you don't have to look down. You just look straight out.
I'm still waiting for an explanation.
So I've just said to you, if you're on a ball, you've got to tilt your head down to see the horizon. So if I climb up a building, I am looking down at the ball. If I'm on a flat plane and go up, I just keep my head 90 degrees straight forward and just look straight forward.
Yeah, great. How is it that the sun appears to disappear behind a horizon when you're higher up if the Earth is flat? Still waiting for an explanation.
Because the higher you go, the further you can see.
Okay, let's do this a different way because you're not getting it. So if I'm higher up, I can see farther. That's your explanation, right?
Looking straight forward, yeah.
Okay, but the sun is not. Okay, so let me put it this way. If you're on the ground versus you're in a tall building, is the sun closer to one of you?
Is the sun closer?
Yeah.
No.
Okay, so then your explanation fails because the sun disappearing from view is based on how far away it gets from you in your model. But the person on the ground and the person in the building, the sun's the same distance from both of them. But the other person, the person that's high up, can see it for longer. Again, that's completely consistent with being able to peek over the curvature of the Earth if you're in the tall building. It makes zero sense for a flat Earth.
They still have line of sight, the person on the ground. It's just the atmosphere stopping them from seeing the sun. That's all. If the atmosphere wasn't so dense, they would be able to see the sun.
Is the atmosphere less dense if you're on top of a building?
As you go up, you can see further. That's why.
Is the atmosphere less dense if you're on top of a building?
Where? At the horizon.
Is the
Or in front of
atmosphere
you.
less dense if you're on top of a building?
Yeah, so the density reduces as you go up for you.
Once you go up many thousands of feet, yeah, but not for
It's less dense,
not
yeah.
for a
So if you're on the ground, you're looking through more dense atmosphere, so you can't see the sun when it disappears, right? Because of the atmosphere. You see?
no, nobody
You
sees.
just answered it. You just answered it yourself. You just
No,
said
I
it gets
didn't.
less. You just said it gets less dense as you go up, obviously. So if you're on the
Thousands
ground,
of feet, yeah.
so if you're on the ground, it's more dense. It's going to make it more harder to see. Exactly.
The
Right?
air is less dense, so it's harder to see. That's the exact opposite
Bro,
of how that
nobody said
works.
that. I said, as
You
you're on the
just
ground,
said that.
I said, you're on the ground, it's more dense, it's going to be harder to see.
Oh, right. Well, maybe I misheard.
Yeah, because you're trying to get a gotcha, and this is what we do. We wrap flat globe earthers up around their own ball, right? Because you don't have the evidence. You just have what you were told and what you believe. Whereas I can prove it with evidence. I can show you. I've shown you a couple of things, and you've been like, "Whoa, how do I explain that?" Which you can't, right?
No, yeah, I can. The conditions in the atmosphere change day to day. It's called weather. But
So there you
a
go.
person in a tall
That
building always sees the sunset after the person on the ground, which is 100% consistent with a globe Earth, right?
because they are higher.
So the question is that consistent with a globe Earth?
No, because on a globe you have to look down. How many times should I say this? You look down at the horizon. You go up, but you look down. On a flat plane, you just look straight out. Don't look down. You just look straight out. You see more land.
Do you know those bridges that have a hump on them?
Yeah, I think so. Yeah.
So if you were standing on one end of the bridge and somebody else was standing on the other side of the bridge, that hump would cover them up, right?
Yeah, that'd be obstruction.
But
Yeah.
if you got a scissor lift and you went up, then you could see the person on the other side of that hump. Exactly like
I'm not
how
gonna be
if
rude, but
exactly like the way that if you're in a tall building, you see the sunset later because you can see over part of the curve that people on the ground can't see over.
I'm not sure if you're deaf or
100%
something.
consistent with a globe
I'm not
Earth.
disagreeing with that. Yes, but you have to look down.
What does that
You're
have to
not
do with
getting that part.
anything?
Because of the difference. On a curve, you look down around the curve, around the corner. On a flat plane, you just look straight out. In front of you. You don't tilt your head when you go up on a flat earth.
So what?
Right in,
Okay, you
on
you
the-
do realize that the sun is above you always on a flat earth, right?
yeah.
Okay, then how come if you're on a really tall building, when you try to look at the sun during sunset, you're looking down?
You don't have to look down, is what I'm trying to tell you.
Well, that's just factually incorrect, but whatever.
On a flat plane, you just look straight out.
No.
Just like you do when you're on the
Have you
ground,
ever
you look
have
straight.
you ever flown in a plane before?
Been in many planes, yeah.
Have you ever been in a plane during sunrise or sunset?
Probably not, no.
Okay, well, I've experienced that, and the sun is below you. So do
The sun
planes
is
fly
below?
higher than the sun?
The sun is below you.
Yeah, you have to look down to see the sun when it's setting or rising when you're in a plane. So is the sun below you? Do planes fly higher than the sun?
Well, you're probably looking at the apparent sun then, not the actual sun.
Right, so there's the cope.
Well, in your model, it says apparent sun. That's where I get it from.
What do you want to talk
You got the
about
apparent
next?
sun. Well, I mean, this is why you've got these topics up here about the flat Earth. I thought it'd be, we could have a back and forth on that, but it's difficult for globers because you haven't been given anything to prove. That's so it's not your fault. I get it, but that's why I have to press you because you believe it, right? So I'm pressing you to say, well, prove what you believe. And all you can do is just tell me that, somebody somewhere somehow has done it, right? Just like a religious person would tell me, right?
So the question was, what do you want to talk about next?
Well, I mean, are you conceding that it's just a belief?
It's a belief predicated on evidence and new evidence that gets discovered every single day. Therefore, it's justified.
Yeah, but not that you've tested or seen or replicated, right? You just read about it.
Yes, I
somewhere.
have. I have been to the ocean and seen the horizon. And I have with my own eyes understood that the sun, the disk of the sun disappearing below the horizon can't possibly make any sense on a flat Earth. In fact, the fact that we can see a horizon makes no sense with a flat Earth, because if the Earth were flat, then much like on a foggy day, the ground and the sky blur into each other. They don't cut off at any point, but there is a sharp horizon on many, I would say most of the days.
Yeah, that's fine. That's because of perspective. That's because the ground and the sky ramps down, the ground ramps up, giving you an apparent convergent point, like a train track appears to come together, but they're not actually coming together, right?
Yeah, except if you zoom in on train tracks, then that convergence opens back up. Whereas with the horizon, you zoom in on it and that doesn't happen.
Well, it depends. It depends, actually.
On if there are certain atmospheric conditions, yes, it can depend.
Right, so it can happen. That's what I'm saying. That can happen, right? So
Yeah,
if there's a
sometimes they get blurred into each other, but on many of the times they don't.
no, you're just going by what you've seen on television, not actually in the real world, right?
So that video that you were showing, when you kept saying, the guy went to the same elevation, that wasn't you, was it? So you just blindly believe in your own flat religion.
No, that's showing that the horizon is
No, yes, actually. So you blindly believe in your own religion because you haven't done the experiment yourself.
I don't have to have done it myself. You don't have to have done it yourself. I asked you to give me a link, didn't I? I said, tell me what I should write to find your evidence, right? I don't expect you to do Cavendish. I want you to show me a scientist who's doing Cavendish in a vacuum. That would be science, right? Is it repeatable? Can we demonstrate it? So what we have flat earthers going around the world, and they do observations, and they show that the horizon's not where it's supposed to be. We've been lied to, you know?
Remember when you guys made a documentary and then you shone that really bright light through that hole? And then you said, haha, if the earth is flat, we'll be able to see the light. And then you couldn't see the light. So then they're like, what the heck? Raise the light up. And then they could see the light, therefore proving that there's a curve to the earth. That was pretty funny.
Yeah, well, I don't think Jeremy was clued up about the atmosphere conditions at that time. That was only 2016, 17, very early on. We didn't know much about the horizon or how it works back then. Now that more
So again, like with the weight thing, the gravity doesn't exist model says it weighs less if you take the air away. It weighs more. So the gravity doesn't exist model has failed. The earth is flat model said the light will be visible. It wasn't. So now we have this post hoc cope of you saying, well, the atmosphere is...
Yeah. Again,
at least you admit it. What do you want to talk about next?
Well, I think that's pretty much it, really. I mean, you said that next
You've
time
had
you're
it?
going to
All right.